So hello everyone, this is week 13 and we start with another new topic, another new lecture. The topic that we are going to discuss in this week is sorting and searching. We need to sort and we need to search. So first of all, let's just talk about what is sorting and what is searching. Now we are going to discuss sorting an array and searching something in an array. So sorting means arrangement of the elements in a particular order. So you can either sort it in ascending order, that means from low to high, or in descending order from high to low. So sorting means arrangement of something. So for example, if I have an array of for example like 3 numbers, I want to sort it, I want to arrange it in a particular order, let's say ascending order. So sorting the array in ascending order, I will have 2, 11 and 88, and if I sort it in descending order, I have the elements 88, 11 and 2. So this is called as sorting. Now searching means you want to find out whether a particular element exists in an array or not. So for example, if I want to find out element 11 exists in the array or not, that means I'm searching for something. So these are the two techniques we are going to talk about in this lecture. We have many sorting algorithms, we have many searching algorithms, but we are going to talk about only 2 algorithms. Alright, so let's just talk about all these. So we will start with first of all sorting, and then we will move to searching. So in the sorting algorithms, we are going to discuss 2 sorting algorithms, which is bubble sort and the selection sort. And in the searching algorithms, again we are going to discuss 2 types of searching algorithms, which are linear search and the binary search. Alright, so let's start with sorting technique, and the first sorting technique that we are going to talk is the bubble sort. Bubble sort algorithm is a very simple algorithm which is actually taught at the introductory level, and it's the basic algorithm of sorting. It is very simple to code, but its running time leaves much to be desired because it takes a lot of time. The name implies the bubble sort algorithm works by having the largest element in the list. That means it bubbles out slowly, which moves to the end, and the smallest element slowly moves to the beginning of the array. This is done by comparing every adjacent pair of values and swapping them if the first one is greater and the second one is smaller. So we are doing actually sorting in the ascending order. This is, I'm talking about, by default I'll be talking about sorting in the ascending order. So each pass through the list keeps track of whether a swap has been made or not, and the process runs through the list of repeatedly until no swaps are made, and then the loop will terminate. Alright, so we have this coding, this is the coding for bubble sort algorithm. I'll take an example also. So we have assumed an array, and the array has 6 elements. You might be knowing array.length property. So we have 2 loops, outer loop and the inner loop. Outer loop is for traversing the array and inner loop is for making the comparison. So what we are doing is for j is equals to 0 and j is less than array.length j++. So I have an array, assume the array j, and I is equals to 0, I is less than array length minus 1. So my inner loop will traverse one element less than the length of the array. That means the length of the array is 0, 1, 2, 3, 4, 5. So it will traverse for the 4 elements. 0 to array length minus 1. Then we are comparing every ith element, we are comparing with the every next element. So if I is equals to 0, it will be compared with array element at I is equals to 1. So if the element at 0th location is greater than element at first location, then what we are going to do? We are going to swap the elements, and for swapping the elements we have a code. So what we do, we declare a temporary variable, and the element of the array where we are currently pointing, we put that element into the temporary variable, so that the element at ith, the array element at ith location becomes empty. Then the element at the next position, that means the first position, we put it in the array space of ith element, and whatever value we put it in the temporary position, we put it into the next element which is at the first position. So after doing this, same thing we will do. I becomes 1, so we compare the array element at first location with the array element at second location. If the array element at first location is greater than the second, we swap it. If it is not, otherwise if it is not, so what we do, I is incremented, and then we move on to j is equals to 1. So again the same thing will happen. So this is quite a slow comparison and quite a long algorithm. Alright, so what happens is, initially I have j is equals to 0, right, and I start with I is equals to 0, right. Now if you see, if you go back, for j is equals to 0, the inner loop repeats until for the array length -1. When j is equals to 1, again the inner loop repeats. When j is equals to 2, again the inner loop repeats. So inner loop repeats for the length of the array for each successive increment of j. So when j is equals to 0, so I have an array, for example this one, 3, 5, 4, 0, 9, 2. So this is element at 0 position, 1, 2, 3 and 4. Now the outer loop j is used to control or to define how many times my loop should repeat. So this is for, the outer loop is defined for repeating the number of times for the loop repetition. So what happens is, now I is equals to 0. So when I is equals to 0, so this is I and this is I plus 1. So what happens is, when I is equals to 0, I go to the algorithm, I is equals to 0, so what it will do, it will compare AI with AI plus 1, that means compare 3 with 5, right. If AI is greater than AI plus 1, is AI greater than AI plus 1? No, AI is not greater than AI plus 1. So what will happen now? Nothing will happen now, and I will be incremented. So now what is I? I becomes 1 now. So I at 1 is 5. So AI is 5, AI plus 1 is 4. So now 5 is compared with 4, AI and AI plus 1. So is AI greater than AI plus 1? Yes, AI is greater than AI plus 1. So what happens is, we swap these two elements and 4 becomes in the position of 5 and 5 goes to the position of 4. So we swap it. Now I is incremented, so I becomes now 2. So what is the element at position A2? It's 5, and AI plus 1 is 9, that is A3. Now we compare 5 with 9. Is AI greater than AI plus 1? No. So nothing happens. I is incremented. So I becomes 3 now. I becomes 3 now. And what is the array element at position number 3? 0, 1, 2, 3, 9. So AI is compared with AI plus 1. Is 9 greater than 2? Is AI greater than AI plus 1? Yes, AI is greater than AI plus 1. So what happens? We swap them. And remember, my inner I loop traverses array length -1. So there are 5 elements. It will traverse for 4 number of times, right? So now what happens? So now my inner loop terminates. Now what happens? J is equals to, J becomes 1, right? Now when j becomes 1, the whole inner loop repeats just like the same. So we compare I is equals to 0. We repeat the same steps again. So the outer loop is actually controlling the number of passes we should make, the number of times my loop should be repeated. So AI is compared with AI plus 1. So 3 is compared with 4. Is AI greater than AI plus 1? No. So what happens now? I is incremented, I is equals to 1. So here I was 0, I is equals to 1 now. So now 4 is compared with 5. Is 4 greater than 5? No, so nothing will happen. Now I is incremented, I becomes 2. So now 5 is compared with 2. Is AI greater than 2? Yes, AI is greater than 2. So what we do? We swap it. Now I is incremented to I is incremented, I becomes 3. So now 5 is compared with 3. Is AI greater than AI plus 1? No. So we don't do anything. Now what we do? We increment j. J is equals to 2. So same thing we do it again. Now I is equals to 0. So 0th element is compared with first element, 3 with 4. Is it greater? No. So nothing happens. Now I becomes 1. AI is compared with AI plus 1. That means one element at first position is compared with element at second position. Is it greater? Yes, it's greater. So what we do? We swap them. 2 comes over here. Next, I is incremented, I becomes 2. So we compare 4 with 5. Is it greater? No. I becomes 3, we increment I becomes 3, we compare 5 with 9. Is 5 greater? No. So now what happens? J is equals to, J is incremented, J is equals to 3. Remember, the J will be repeated the number for the number of elements in an array. I have 5 elements, 0, 1, 2, 3, 4. So J will be repeated 5 times, whereas I is repeated only 4 times, 0, 1, 2 and 3, because array length minus 1. Alright, so when J is equals to 3, same thing happens. I is 0. So 0th element and the first element are compared. Is AI greater than AI plus 1? Yes, AI is greater than AI plus 1. So what we do? We swap it. Next, I is incremented, I comes at 1 position. Is AI greater than AI plus 1? No. So nothing happens, only I is incremented. So I becomes 2. So next, AI is compared with AI plus 1. Is AI greater than AI plus 1? No. Nothing happens, I increments, I becomes 3. Same thing happens. Is it greater? No. So my inner loop is complete. Now J is equals to 4. So it becomes up to now array length now. So again I is equals to 0. We compare with compare 0th element with the first element. Is it greater? No. Nothing happens. I becomes 1. Element at first position is compared with the second position. Is it greater? First element greater than second? No. So nothing happens. Next, I is incremented 2. So the element at second position is 4. 4 is compared with next element which is at third position. Is it greater? No. So nothing happens. We increment I, and now our loop stops. No changes, no swaps are made in the last run. So we are done. So this is a very basic example of sorting a list in an array. Although it takes a lot of time, the running time or the processing time is quite higher as compared to the other algorithms. So if you see, in case of ascending order, if we want to sort the list in ascending order, the lowest element slowly, very slowly comes to the beginning and the highest element moves at the end. So if we want to do sort the list in descending order, what we have to do? We just have to reverse this, we have to change this comparison operator. Alright, so moving ahead, our next algorithm is selection sort, which is quite better algorithm than the bubble sort. A selection sort is another fairly simple sorting algorithm. It is more efficient than the bubble sort, and selection sort works like this. We consider that there are two parts of the array. One is the unsorted zone and another one is the sorted zone. So in the loop, what we do, the highest element from the unsorted zone is selected, and hence it is called as the selection sort. So we select the highest element from the unsorted zone and we name it as the selection sort. That's why it is selection sort. And the highest element, what we do, we place it at the end of the unsorted zone. After that, the sorted zone expands to cover the recently moved element and the unsorted zone shrinks. So unsorted zone shrinks and the sorted zone expands. Eventually the sorted zone becomes the entire array and the unsorted zone disappears. The array is then considered to be sorted. Alright, so how does this works? How does the algorithm works? We have an array, and now here we are not moving from first element to the last element, rather we will traverse from last element to the first element. So from where we start from the array length -1, not from the last element rather than the second last element. We consider that this array is our sorted zone. And what we do, we keep on decrementing the index of the array unless and until the index is greater than or equal to 0. So in this, what we do that we consider a variable highest index and move I to it. I is what? The highest index. That means where I am, my current pointer where is. We have the inner array. And inner array starts from my current position, which is I, and we keep on decrementing. So while we keep on decrementing the index of the array, we check that if the current position is greater than the highest index, then what we do, we put the current element or the current index as the highest index, and then we swap them as usual we did it. And after that j is again decremented. So this is done for each of the j is again decremented, and after doing it for one pass, then we decrement the index of the I. Let's just do an example of it. Alright, so now we start with this. This is my array 35492. Now as we discussed that we are going to start from the back of the array and then we will move towards forward. So we start with I is equals to array length -1. So this is my last element, and we assume that this is the highest element. That means at this point my array is sorted. So what are the elements of the array? I have 3, 5, 4, 9 and 2. So I am at this point, I is at this point. Now what we do, this is the highest element, highest index is I. So what we do, j is equals to I, we move to the inner loop and we compare 2 with 2 is pointless. So we compare 2 with the 9, right? Because 2 is the highest index over here. That is the highest index. So we compare 2 with 2, comparing 2 with 2 is pointless. So what we do, we decrement the value of I. Now my I value becomes this, alright. So we compare 2 with 9, because if I go back, j will be decremented and now my j becomes, my highest index is 2. So when j is decremented, this is the value at j and this is the value, 2 is at the highest index. So what we do, we compare array at j, is it greater than the array at highest index? So now we compare array j with the highest index. If I go back to the code, array j greater than highest index, array at highest index. So if it is greater, then j becomes the highest index. So initially my last element was the highest index. So now when we decrement the value of j, now we compare the array element at j position with the array element at highest index. If j is greater than the array element at highest index, so this will become my new highest index. So if I go back, so if it is something highest index, if it is highest index, yes, it becomes the highest index. Still we will not go out of the loop, because we need to find out first of all which is the highest index. So my 9 becomes the highest index. Now we decrement the j over here. Now that we decrement the j over here, so j is decremented. Now j becomes 4. We compare 9 to 4. Is j greater than highest index? No. Then we decrement the j becomes 5. Is j greater than highest index, which is 9? No. J is decremented. Is j greater than highest index? Is j greater than highest index? No, it is not greater than highest index. So we have traversed all the elements. So what is my highest index? My highest index becomes j. My previous highest index value was 2. So now highest index becomes j. Now in the array we have chosen the highest index value. So now we are going to swap these two values because my initial highest index was last element. So now what we do, because we found our highest index value, the highest element. So now what we do, we swap 2 and 9. So this zone becomes now sorted zone now. So after the first pass, I have the array which is something 3, 5, 4, 2 and 9. So this becomes my sorted zone now, and this is my unsorted zone now. So if I go to the code, now array I is decremented, right? So now we go to the I becomes 2 and we compare 2 with 2, which is pointless. Alright, so it becomes my highest index. Now we go to the j, and j decrements now. So j becomes now 4. So is array at j is greater than array at highest index? Is 4 greater than highest index value? My highest index becomes now 2. So is 4 is the new 4 greater than the highest index value? Yes, it's greater. So now my 4 becomes the highest index value. Now in the next pass, I decrement the I becomes 3. So now 5 is compared with 4. Is array at j greater than the highest index value? Yes, array at j is at the highest index, greater than the highest index value. So j goes to the highest index. That means j is the index position of the 5. So now 5 is the new highest element. We decrement I and we compare 3 with 5. So is 3 greater than the highest index? No, my 5 is the highest index. So we were comparing 5 with 2, right? So my 5 became the highest index. So what we do now, we just interchange that value. So what is my array now? 3, 2, 4, 5 and 9. So that means these two positions are sorted. These two positions are sorted, and this is the unsorted array. So sorted is shrinking, sorted array is expanding and unsorted is shrinking now. Now my I becomes at 4. So comparing 4 with 4 is pointless. J is equals to I. So this is my jth element. This goes to the highest index. We are not concerned with the last two elements now. So j goes to the so now we compare j with the array element at the highest index, which is at 4. So we compare 2 and 4. Is array at j greater than the array element at highest index? No. So we just leave it. Alright, then what we do, we decrement j and we compare 3 with 4. Is array element at j greater than array element at highest index? No. So nothing happens and we don't do any swapping over here. Now in the third pass, what happens? Now my array is 3, 2, 4, 5 and 9. So this zone is now sorted zone, and this zone is 3 and 2, they are in the unsorted zone. Now my 2 is the initial highest element. So comparing 2 to 2 is pointless. So my jth element is 3. Now what I do, I compare array at j position with the highest index value. Is array at j greater than highest index? Yes, it is greater than. So my 3 becomes highest element, and as I don't have any other element, so what we do, we just swap them. So my array becomes 2, 3, 4, 5 and 9. So this is my sorted zone now, and this is my unsorted zone now. So now my 2 is the highest index, and comparing 2 to 2 is the highest index. Swapping 2 to 2 is also pointless. So we are done now, and at the end my sorted array is 2, 3, 4, 5 and 9. So this is how the selection sort works. Now let's talk about the searching algorithms. The two searching algorithms that we are going to talk are linear search and the binary search. Linear search is a very straightforward loop. So this is something you might use in a daily life. For example, if you are searching for something, whatever you have in hand, you will try to match it with everything, whatever you look for. So for example, if you have some color in your hand and you have a color palette, you want to match the color that you have in your hand with the color palette. What you will do? You will match the color that you have in your hand with each of the color in the color palette. So that is called as the linear search. This is a very straightforward loop comparing every element in the array with the key. So as soon as the equal value is found, it will print at stop, and if the loop finishes without finding a match, it will just display that cannot find a key, or the key does not exist. Alright, so for example, we have this array. The name of the array is sorted. I have these elements and this is the key. I want to find out this key. So we will traverse for all of the array. Now for each of the element we will check if key is equals to sorted I. That means my array I is equals to 0. This is I. So array at I is sorted 0 is 80. Is 80 equal to 222? No. So what will be done? I will be incremented. Now I becomes 1. Is 12 equal to 222? No. So I will be incremented. So is sorted array at position number 2 is equal to 222, which is equal to 222? No. I is incremented and so on. And at last the element is found, so it will print found and exit the system. Suppose if this number is something 416, so in that case element is not found, so these statements will not be executed and it will print that the array element could not be found. So how it happens, I just explained you. First of all, we start from element 0. 80 is compared with 222, it's not the same. Then we increment the I. So 12 is compared with 222, not the same. I is incremented. The third element is compared with the key, not same. Then I is incremented. 400 is key is compared with this element, not same. Then I is incremented. 5 is compared with our key, not same. And at last 222 and 222, they are equal, and hence key is found. The last algorithm for searching is binary search algorithm. It's the fastest way to search a sorted array. Binary search is a fastest way to search a sorted array. Now in this case my array should be sorted. So linear search can work on the array even though it is not sorted. So if you see my array is not sorted, linear search can work. But binary search, we can make a search in a sorted array. So if we are using a binary search algorithm on some array, so first of all we need to sort that array. You can sort the array using any of the sorting techniques which we have discussed now. So the idea behind the binary search, the first thing is your array should be sorted. So if your array is not sorted, first of all you have to apply some sorting algorithm. So the idea behind the binary search algorithm is to look at the element in the middle. We first of all, for example, if we have some array, we find some middle element. So because my array is sorted, so middle element, if we find some middle element, that means the element towards the right of the middle element will be the higher elements, and the element towards the left of the middle elements will be lower than this. So what we do, we check the key. If the key is equal to the middle element, our search is finished. Now what we do, if the key is less than whatever the middle value we have found, so we apply the same principle. We search towards the left of the array and we apply the same principle. We find the middle element and do the same thing. But if my key is greater than the middle element, we do a binary search on the upper half of the array. That means we again find a middle element, compare our key, and if it is not equal to the middle element, we again search. So the idea is we should have a sorted array. Now if you look at the example, the array elements that I have taken, they are sorted over here. The array elements are sorted over here, and the key that I want to find out is 55. So binary search always works on your array should be sorted. Alright, so I have taken two other variables, first and up to. So first is 0 and up to is sorted length minus 1. So sorted length minus 1. Sorted length, what is the length of the array? 5. 5 minus 1 is 4. So first is 0 and up to is 4. While first is less than up to, what is my first? 0, and it is less than equal to 4. What are we going to do? We are going to find the mid of the element while this is less than this. So what I am going to do? I am going to compute the middle element. So 0 plus 4 divided by 2 is equals to 2. So my middle element is element at the second position, 0, 1, 2. So after finding out the middle element, what we are going to check? We are going to check if key is equals to sorted mid. Is my key equal to the middle element? If yes, that means I have found the key. Otherwise, I will check if key is less than sorted mid. Is my key less than the value which is over here? If it is less than the value over here, then what will, if my key value is less than the value over here, what will I do? So if my key is less than the sorted element at the middle, what will I do? I will repeat the search in the bottom half. So what will I do? Up to I will compute as mid minus 1. I computed the mid as 2. 2 minus 1 is 1. So up to means up to will have 1. Again I will follow the same thing over here. Otherwise what I will do? First is equals to, so what will I do? First is equals to mid plus 1. What will I do? I will compute the search in the top half. So first will have 2. I found the mid 2. 2 is what? 2 plus 1 is 3. That means I will start my search from index number 3. So I will repeat the search in the next half. So this will continue unless and until first is less than equal to up to, and at the end either I will have a key is found or key is not found. Alright, so let's assume over here my key is 222. Now I have 6 elements. In the example I have 5 elements. I have 6 elements over here. Alright, so the elements first is 0 and up to is 1, 2, 3, 4, 5, 6. 6 minus 1 is 5. So 0 plus 5 divided by 2. So it should be something. So what we are going to do here is, now when we added 0 plus 5 divided by 2, we get 2.5. Now here we are going to use the ceiling of a value, right? Ceiling of a value, it gives us a number largest, greater than or equal to our current what number we have. So we are going to take a ceiling of the value because I can't have a number at 2.5 position. Either I can have a second position or a third position. So we are going to have a ceiling of a value will be considered. That means 2.5 will be made at 3. So that means my middle mid is found at position number 3. So this is position number 3. That means my mid is found at position number 3. This is my mid value. So according to the code, what I do, I compare the key with the sorted. This is my sorted mid, right? So sorted mid is found at position number sorted sorted 3 element, or if I say position number 2, because 0 1 2, this is position number 2. So I compare my key with this middle element. Is it equal? No, it's not equal. So now I will check whether it is greater than or equal to. Is my key greater than this element? Yes. Is my key less than this element? No. Is my key greater than this element? Yes. So what will I do? I will search in the upper part of this array. That means after my middle element, I will start searching. So for this, in the code, if I go, I have first will be mid plus 1. What will be my first? What will be value in the first now? Previously we had 0. So mid plus 1. So my middle element was found at position number 3. So it will be 3 plus 1, which will be equal to 4. So we have to find out the same thing, middle element. So mid will be computed as first plus up to divided by 2. So what is my first? 4 plus what was the value of up to? 5, right? Because number of elements minus 1. 4 plus 5 divided by 2. 5 plus 4 is 9. 9 divided by 2 gives me 4.5. 4.5 when I seal it gives me the position, the fifth element, right? So the fifth element is 55. So now I have this as the middle element. Out of these three, this is the middle element. So now what will I do? I will check, is my key equal to the middle element that I found? No, it's not equal. Is my key less than this? No, it's not less than this. Is my key greater than this? Yes, it's greater than this. So what will I do? I will now again compute the first element. So first will be computed as, how I will compute? Mid plus 1. So first will be computed as mid plus 1. So what is mid? Element at 5. 5 plus 1 is what? 6. Because now I don't have any other element after this, so this becomes the mid element. Now I compare my key with this. Key is found. Key is equal to the mid element, so hence my key is found. So this is how the binary search algorithm works. So this is all about sorting and searching techniques. We are going to do certain programs based on these techniques. So thank you so much.